Jai Hind to all of you. I am Priyanka Sharma, Assistant Professor, EC Department. I am going to present my video lecture in Fundamentals of Electronics Engineering, that is BEC 101. In this lecture, I am going to cover up the complex topic of Unit 4, that is Digital Electronics. In this lecture, we will going to cover up the K-map, that is Carnot map. So, the contents of our lecture will be, basically, we are going to emphasize on the K-map minimization up to 6 variable. So, let us start with first know about what is digital electronics. Digital electronics is a field of electronics that is going to involve the study of digital signals, and in this we are going to study about the comparison of analog signals and digital signals. So, basically digital electronics is dealing with the digital electronic circuits which can be made from a large assembly of the logic devices. Logic devices going to include the logic gates, which is packaged in the form of integrated circuits. So, basically the complex devices may have some simple electronic representation with the help of Boolean logic function. So, in this lecture we will basically going to cover up that how the complex Boolean functions can be minimized with the help of K-map. So, earlier we was able to do the minimization with some Boolean algebra formulas, but that takes a lengthy amount of time. So, to minimize that amount of time and to simplify our calculations, we can going to switch over the K-map. So, if we first start with 4 variable K-map, first of all, what is K-map? K-map is basically the minimization techniques that is going to applied for the min terms and the max terms both. So, for the min terms, we have to emphasize on sum of product terms, and for the max terms, we have to emphasize on the product of sum terms. So, we have basically two types of terms, SOP and POS. So, if I am going to cover up, first going to fundamental, SOP is corresponding to min terms and it is corresponding to the representation as summation of min terms. We are going to represent this in this way. And this min terms, suppose I am taking this as 0, 2, 4, randomly I am taking these numbers. So, this min terms is basically corresponding to logic 1. And next is POS, that is product of sum term. This is corresponding to max term and this is represented as product of max term corresponding to, let us say this is 1, 3, 6, 7. So, this is basically corresponding to logic 0. So, this can be basically represented as, suppose this is 0 and if it is a 3 variable, then we can represent 0 as, logic 0 as A bar, B bar, C bar. Now, logic 2, this is represented as 0, 0. 2 is represented as 2, 1, 0, that means A bar, B, C bar. So, this is the representation of sum of product. If we want to represent in terms of product of sum, so if we want to represent 1, that means we have 0, 0, 1. So, because in this we have the logic, it is corresponding to logic 0. So, we have 0 corresponding to, we will going to write 0 as A and this is 0 as B and this 1 as C bar, and this will going to represent in the form of sum of product of sums. So, this is one term and suppose if we have 3, that means 0, 1, 1. So, 0 can be represented as A, this can be represented as B bar, this is C bar, this is plus. So, this is called as product of sum term and this is called as sum of product. So, we have these two terms that is min term and max term. So basically K map is going to represent all these SOP and POS terms. So we will first going to solve the K map with the help of sum of product terms. So we have first 4 variable K map. So this is the way of representation. K map is the representation in the form of blocks. So if we have a 4 variable K map, we have 2 to the power 4 blocks, or that means we have 16 blocks in this. So 16 blocks can be drawn like this, and the numbering can be done as, in this we are going to number this. We have 4 columns and 4 rows. So 4 columns can be represented as, if I am suppose this is taken as AB, this is AB and this is CD. So this numbering can be taken as 00, 01, 11 and 10. That means each row should have only 1 bit change. That's why we had interchanged the third column and fourth column. So this can be interchanged like this. Also this 00, because we are assuming this as a min term, we are taking sum of product terms here. So this 00 can be represented as A bar, B bar, this is A bar B, this is AB and this is AB bar. If we can write CD here, 00, 01, again 11 will be come here. That means we had interchanged the third and fourth column. So again we can write here as C bar D, C bar D bar, C bar D, CD and CD bar. So numbering will be like this only. So we are going to number this 0, 0, 0. That means 0 correspond to 0 min term, first min term, then 2 is shifted backward in the fourth column, then 3, 4, 5, 6 will be shifted fourth, then third column. And again 8 will come to the fourth row, because we had interchanged these 2 row also. So 8, 9, again 10 in the fourth column, 11 in the third column, 12, 13, 14 in the fourth, 15 in the third column. So in this way you will going to number the different blocks of the 4 variable K map. So this is how we had filled the min terms, numbered the min terms. Now we will going to fill this according to their min terms logic. So if min term logic is 1, we will going to fill it in the box, and corresponding to 0 we will going to put it 0. And after this K map is solved for only the min term logic corresponding to 1. So we will going to solve it. We have this box and we have given the output as logic 1 is corresponding to this variable 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have this as 1 logic, 1, 1 and corresponding to 2. So we had calculated the min term values here. So we have min terms corresponding to 0 logic, 1, 2 and then it is coming for 6. So we had written here 6, then it is coming for 8, 8, then for 10, then for 13 and 14. So we had written here all the min terms. So after this we will going to form the K map and substitute their logic 1 corresponding to each min terms. Now we have certain rules to solve the K map. So we can first going to form the different groups. First we are going to form the maximum number of groups. So maximum we have 16 blocks. So we can form the 16 1 logic groups, 16 ones logic group. So we didn't have any 16 ones logic group. Secondly, we will going to calculate 8 ones logic group. So we also didn't have any 8 ones logic group. The condition is it should be the adjacent ones. So here the adjacent ones in the form of 8 group is not present. So after this we will going to form the 4 ones logic group. So this is coming here, either it is vertical, any adjacent groups, any adjacent logic pairs we can take. So we have ones here. So this form one group. This is called group 1. I am taking this as group 1. And this is, after this we don't have any other force. We have other force. We can also take the corners 1 logic. So we can take the corners 1 logic we have taken here. So this is forming the group 2. And after this, or another condition is overlapping will be allowed. This one is already in this group, but we can take it with this another group. The condition is only one logic 1 should be free. So the one here, the 1 is free, so we can form the group of 4 here also. So this will be treated in the form of group 2. After this, we don't have any 4 ones logic. Now we will come to the pair of 2 ones logic. So 2 ones logic are coming here only. This is the 2 ones logic. So this is I am taking as group 3. After this one cannot be paired with this because this is already in pair. There should be one, at least one free logic 1. After this one is single left. This is not forming any group with any other ones. So this will be taken alone. This is called group 4. So by writing the corresponding min terms corresponding to different groups, we can get the simplified output. So for this we have, first of all, if we start with group number 1, group number 1 is corresponding to column CD bar. In this CD bar, A bar, B bar, A bar B, AB and AB bar, this all gets sum out to 1. This all gets sum out to 1. Because in this B bar and B is 1 bit change, or in this A bar and A is 1 bit change. So this will going to sum up to 1 value. So only we left with CD bar here. Now G2. G2 is the group of 4. So in this we're going to take first column, fourth row, first column, fourth column. So by taking these two, first row and fourth row, if we'll see, A bar has a 1 bit change, so it will be taken as 1. It will be sum up to 1. So only B bar is left here. And in first column and fourth column, C bar, D bar and CD bar, that means C bar C sum up to 1, only D bar will be left here. After this, G3. G3 is the pair of 2. So AB bar is only single row, so this will be taken as it is. That means G3, A bar, B bar will be taken as it is because only single row is there. And if we compare these two columns, column number 1 and 2, in this D bar D will sum up to 1, so only C bar will be left here. And the last group, that is G4, it is taken alone. So it is a combination of third row and second column. So it will be taken as A, B, C bar, D. At last, if we will going to sum up, we will going to obtain the simplified output of this Boolean expression. So this is how we can solve the 4 variable K-map. So first we had to understand the basic of 4 variable K-map. After this, I am going to cover up the 6 variable K-map. 5 variable K-map. Now, if we are going to understand this 5 variable K-map, 5 variable, that means we have how many number of boxes? It will be 2 to the power 5. That means it is taken as 32 box. We have to take 32 box. So 32 box K variable K-map. Making this such a 32 variable K-map box will be very tedious task. So it can be split up in the form of 4 variable K-map by assuming it in the form of table. How we had split up in the form of 2 boxes? Because we have A, B, C, D, E. We have 5 variables. So we can assume the table 0, 0, 0, 0. It is starting from 0 value up to which value? it will be taken as 0 and it will be coming to 1 1 1 1 1 logic. So this is for this is for a equals to 0. A equals to 0, it form the complete 4 variable K map. 1 4 variable K map. 1 4 variable K map. This is corresponding to logic A equals to 0. So that means we can split up this 5 variable K map in 2 4 variable K map. So now if A is equals to 1, corresponding to 1, we have another set of 4 variable K map, that is starting from 0 0 to 1 1 1 1. So this is also containing 16 blocks, that means another set of 4 variable K map. So we had split up this 5 variable K map corresponding to logic A as 0 and corresponding to logic 1 in 2 blocks of 4 variable, and it can be written as like this. Numbering will be start from A equals to 0. So numbering will be started like this. We had written BC D here. This is BC D here. So it is same numbered as we had interchanged the third and fourth column, and it can be written as B bar C bar. This is B bar C. This is BC and this is BC bar. This is D bar E bar. This is D bar E. This is DE, this is DE bar, and the numbering will be started from here 0, 1, 2 in the fourth column, 3 in the third column, 4, 5, 6, 7, 8 in the fourth row, 9, 10 in the fourth column, 11, 12, 13, 14, 15. After this 15, we will going to start the numbering in the next table, which is corresponding to A equals to 1. So this is equals to, this is numbered as 16, 17, 18 in the fourth column, then 19, 20, 21, 22, 23, 24, 25, 26 up to 31. So this will going to form the 5 variable K map like this. So let us take the example by taking one numerical. Suppose I am taking this numerical for the 5 variable K map. So we had taken all the minterms 0, 4, 7, 8, 9, 10, and we had formed the 2 4 variable K map corresponding to A equals to 0 and A equals to 1. Now next we had filled all the logic ones corresponding to minterms, and after this we are going to start with again forming the groups. So in this case also we can start with the highest number of group, that is 32. First group will be 32, second group will be 16. So is there any group of 16? By comparing these two cubes, these two K maps, there is no 16 groups. After this I am going to take up 8. So the group of 8 cannot be formed in single K map. We can see here the 2 K maps, we have different set of groups. In one K map we have 4 set, and other K map we have 4 set. But they are adjacent to each other. We can assume these 2 K maps to be overlapped. So if we going to overlap this 4 group of ones and this 4 group of ones can be overlapped to form the group of 8. So this can be called as subcube 1. So this is called group 1, subcube 1. After this, we can find, first we are going to find the groups by comparing the 2 K map 1 and K map 2. In that we have to identify how many same number of ones group will be formed here. After this group of 4, we have another set of ones which is common to both the K map. We have here one, this one also form the subcube with this one. So this is at the same place in both the K map. So this can be treated as subcube 3. Before that, before going to the subcube 1, we'll first go into the sequence. So we had first find the 8 group. Now after this if no 8 group is present here, we will come to the group of 4. So we will going to see here that there is no group of 4 which is common to both. So we can also identify in the separate K-map identically. So individually. So in group 2 or K-map 2, we have one group of 4 here. So this is treated as subgroup 2. After this, there is no group of 4. After this, from 4 we will come back to 2. Now if we are going to find out the group of 2, we have one group of 2 here and one group of 2 which I found in both the K-maps. So this is treated as subgroup 3. After this, there is no common group of 2 here. So after this, I am going to find a group of 2 in first K-map, that is treated as subgroup 4. And at last, we have a single one which is coming into K-map 1. So this is how we had identified the groups which is treated as subgroup 1, 2, 3, 4 and 5. Now how to solve this? We are going to solve this. First, we can identify the group 1, subgroup 1. So subgroup 1, we will going to form the two columns. One is corresponding to A equals to 0 and one is corresponding to A equals to 1. So we have two columns and the total value we will write here. So corresponding to A equals to 0, that means we will treat this as A bar. We will write this as A bar and this is treated as A. So corresponding to A bar, this group can be called as, what this group can be called as? This is corresponding to 4th row and all 4 columns will be sum up to 1. So only we left with, this is called as B bar C bar. This is called as BC bar. So this is written as BC bar here. And this same group is present in A also. So this is also called as BC bar. Because this same group is present in both the K-maps, that's why this will going to sum up to 1 and we are left with only BC bar here. After this, come to subgroup 2. Subgroup 2 is only present in K-map A corresponding to 1. There is no subgroup, no group present in K-map 1. So this is treated as 0. But in A, it is present in the form of group of 4. So this can be calculated as, because in A, it is present in the group of 4. So there will be 3rd row and 4th row and 2nd row and 3rd column. So this can be calculated as, this is B bar C bar, this is BC bar and this is D bar E and this is DE. So in this B bar and B sum up to 1. So see, we are left with C bar only. So this is C bar and in this case D bar and D sum up to 1 and only C will be left here. So we will get here, because A bar is 0, so we have the output result will be taken with the A C bar E. Because A bar becomes 0, so it will not get sum up with A bar, A with equals to 1. So A will be included in this. Now for the subgroup 3, subgroup 3, we have 1 present in K-map 1. So this can be written as, what we can write here, BC bar, B bar C bar, B bar C bar and D bar E bar. In both the case, this can be written as B bar C bar, D bar E bar. So and again, because this is present in both the K-maps, so A bar A will be sum up to 1 and we are left with only B bar, C bar, D bar, E bar. So now the subgroup 4 will be taken. Subgroup 4 is taken here. Subgroup 4 is only present in K-map 1. So K-map 1, we have subgroup 4. So we will going to take row 1 and row 2 and we have column 1. So this can be taken as, this is B bar C bar, this is B bar C and the column will be D bar E bar. So column is single, so it will be taken as it is, but B bar C bar, B bar C, C bar and C sum up to 1. So we are left with only B bar, D bar, E bar. But this is not present in K-map 2, so it is taken as 0 here. So after this, what we will take? This A bar will be included here because A is corresponding to 0. So this is written as A bar, B bar, D bar, E bar. So this is subcube 4. Now at last we have subcube 5. This subcube 5 can be written as, this is only present in again K-map 1. So K-map 1, this one is corresponding to B bar C, that means second row and third column. So this can be written as B bar C and third column, that is D E. And again in K-map 2 it is not present. So this is taken with A bar, B bar, C, D, E. And at last we are going to sum up all these min terms and we get the simplified form of this 5 variable K-map. So if we see this, if we see the output of this y can be written as, the sum of BC bar plus AC bar E plus B bar C bar D bar E bar plus A bar B bar D bar E bar plus A bar B bar C D E. So this will give you the simplified form of the Boolean expression. So this is how you can simplify the 5 variable K-map. So similar to that, we can also solve the 6 variable K-map. The concept will remain same. In 6 variable K-map, we have A, B, C, D, E, F. We have 6 variables. That means we can have 2 to the power 6, that is number of blocks will be 64. So this is how this can be split up here. We can split up like this, A, B and C, D, E, F. So C, D, F 4 variable K-map. A, B will form here how many groups? 0, 0, 0, 1, 1, 0 and 1, 1. That means we have to form 4 variable K-maps. 4 variable K-maps for the 6 variable. So we have here 4 variable K-maps. One is corresponding to AB equals to 0, 0, AB equals to 0, 1, AB equals to 1, 0 and AB equals to 1, 1. And the numbering will be, we can do accordingly. First we will start with 0, 0, after that 0, 1, after that 1, 0 and at last we will obtain at 1, 1 up to 63. The concept will be same. Here also if we take one numerical, this is the numerical of 6 variable K-map. In this also we will form the subcubes. We have different min terms here. So we will substitute all these min terms in the boxes and again we are going to form the subcubes here. So we have here 4, first we will start with 64, then we will come to 32, then will come to 16, then come to 8, then come to 4, then 2, then single K. And the same rule will be applicable here also. First we will going to find the match between all 4 or any 2 K-map, If it is found, then we can like here it is given in first K-map AB equals to 0, 0 and 1, 0. We have 2 exactly 4 groups of 1. So we can take this as a subcube 1. Is there any another 4 group matching in any K-map? There is no 4 group. After this we will going to find the individual 4 logic 1s in single K-map. So here we obtained with single 1 in this is called as subcube 2. After this we will going to find out the group of 2. If it is matching in any 2 K-map, we will take this. So we have these 2 ones which is formed in between these 2. So we are going to match up this. So this is treated as subcube 3. After this, if we are going to solve this, we have to form the 4 columns. AB, first we will going to form for AB equals to 0, 0. That means A bar, B bar, A bar B, that is 0 1. We will going to form the 4 columns here. A B bar, that is 0 1, and at last we have AB, that is 1 1. And after that we are going to sum up all these in the same manner as we had done in the group of 5 variable K map. So for corresponding to 0 0, we will going to write the minimized form A bar B and AB bar AB. If it is present here, we will substitute here. If it is not present, we will substitute 0. First, if we take the example of subcube 1, so we have, there is a group of 4. So we have only, this will be sum up to 1. So we are left with only E bar F bar. It is present in only A bar B bar. So we have here E bar F bar here. But it is not present in 0 1. So it will be treated as 0. It is also not present in AB equals to 1 1. So it is here also it is 0 0. But it is present in 1 0. So it can be again written as E bar and F bar. So it can be totally calculated as, we have only 2 columns present here. In these 2 columns also, we will see here A bar and A will be sum up to 1. So we only left with B bar here, B bar, and the common minimized term will be E bar and F bar. So this is how you will going to simplify the 16 variable K map. Okay. So this is how we can simplify the 16 variable K map. So this ends up the lecture of the 16 variable K map, 6 variable K map. So this is how we learn about how to solve weekend K map for different variables. Thank you so much.